Thank you for the opportunity. Let me introduce myself. My name is Trivena Tumimomor. Today I will explain a material. The material is about phase equilibrium. When a system composed of two or more phases is in the state of thermodynamic equilibrium, we say that the system has attained phase equilibrium. Example, liquid water and water vapor are in phase equilibrium at temperature 100 degrees Celsius and pressure 101,325 Pascal. Liquid water at 40 degrees Celsius and ice at minus 10 degrees Celsius are not in phase equilibrium. An irreversible process occurs during which ice heats and melts and liquid water cools. In the state of thermodynamic equilibrium, which the system attains after some time, there may be either a one-phase system, or ice melts, or a liquid water freezes, or a two-phase system with phase equilibrium existing between ice and liquid water at 0 degrees Celsius. When a system is in the state of phase equilibrium, we call its phases coexisting phases. Coexisting phases always have the same temperature and pressure. In the case of multi-component equilibria, the composition of individual phases are identical unexceptionally. The term phase transition applies to a process during which a certain amount of substance changes from one phase to another. Phase transition may be reversible or irreversible. In pure substances, the boiling point is determined by the boiling temperature and the boiling pressure. The normal boiling point is determined by the normal boiling temperature, normal pressure, and the composition of the liquid. The normal boiling temperature is a temperature at which a liquid of a given composition is in phase equilibrium with its vapor at the normal pressure. The dew point is determined by the temperature, pressure, and composition of the vapor phase. In a pure substance, it is identical with the boiling point. The melting point is determined by the melting temperature, melting pressure, and the composition of the solid phase. The normal melting point is determined by the normal melting temperature, normal pressure, and the composition of the solid phase. The freezing point is determined by the freezing temperature, freezing pressure, and the composition of the liquid phase. In a pure substance, the freezing point is identical with the melting point. The triple point is a particular temperature and pressure in a one-component system at which two different phases can coexist in equilibrium. These three phases are normally solid, liquid, and gaseous. So, that's all the explanation. Sorry if there is something wrong because I'm also in the process of learning. Thank you.